So today we are going to be recording or watching lesson 1-8, which is called slope. But your standards actually calls it constant of proportionality. Slope is the technical term it's referred to in 8th grade and in high school, and your parents probably refer to it as slope. We've kind of talked about slope already way at the beginning of the school year when we were doing the graphing calculator labs, when we were talking about linear equations and the lines, and we were discussing the steepness of that line. That steepness of that line is called slope, the constant of proportionality. Now, constant of proportionality and slope and something called direct variation that we're going to talk about, and constant rate of change, which you just did, all of those terms really are interchangeable. They all essentially mean the same thing. It means that it is a constant rate and they are following at that constant rate of change, or it is occurring at that same level of degree. That line is following at that same level of degree. The lesson today is very similar to the lesson that we did on Friday. So I'm going to try something a little bit different today, and we're going to do the video using something called Camtasia. So we'll see how this goes today. It's a little bit different because I'm using a stylus to write, so it's not ideal, but we'll see how this goes. So you can let me know what you think. So today's lesson is slope, and slope is the change in y over the change in x, which again is the same thing that we talked about yesterday or on Friday. So it is your vertical change over your horizontal change, and when you're talking about a line, it is that y, I'm going to turn my little marker on here, it is that change in that vertical over that change in that horizontal. So we call that often your rise over your run. Your parents would refer to that as your rise over your run. I'm not a big fan of that because when you do rise over run, you're counting and you can miscount. Or when you are counting, you have to also keep in terms of remembering whether it is positive or negative. And when you calculate, you don't have to worry about that, because when you calculate, you will calculate whether it's positive or negative. So I'm a bigger fan of the calculation. So the formula that we're going to use is y minus y over x minus x, which is the formula that you used on Friday. So that's nothing new either. It's the same thing that you were doing. It is that constant rate of change, which is written right in here. It's the same thing that we've been doing, or that unit rate. It's the same thing that we've been doing. It is a linear relationship. So none of this is different. Slope, we refer to slope, and you're going to need to know that slope is the constant of proportionality. That is going to be on the Smarter Balanced Assessment. So you have to know that terminology, constant of proportionality. Okay, so your parents, again, will talk about rise over run. That's probably what they were taught. That's what I was taught. Rise over run is challenging because, again, it comes down to counting. I really struggled with that myself when I was in school. So it's not something that I like. Calculating is a lot easier using that formula y minus y over x minus x. So that's the way that I would recommend that you do it. So, okay. So if you could turn your page, please, to page 75, and we'll do our first example. Example number 1 talks about a relationship between the number of seconds y it takes to hear thunder after lightning strikes and the miles you are away from that strike. So you have to tell me what the slope is, calculate what the slope is, and then also tell me what it would be, or what that slope represents. Now, your book does something that I don't agree with. Surprise, surprise. Slope, a couple things. First of all, slope. Oops, I got to turn that back on here. Slope should be written, in constant proportionality, can be written as a fraction. And that fraction can be written as, it's actually a comparison of two numbers, or it can be written as a whole number. That fraction can be improper fraction, but it is not written as a decimal or a mixed number. Now your book will write it as a decimal, and that is not correct. You don't write slope as a decimal. Slope is written as a mixed number, or slope is written as a fraction. So you can see slope as 3/2, or you can see slope as 5/1, or you can see slope as 5 or 1/2. But you will not see slope, in your book will show it as 1.2, but that's not correct. In algebra, you will never ever see it written as a decimal. It's just not something that you see. That's why it's so important that you understand fractions, because you will see it often written as fractions, and you need to know how to do it as a fraction, because they will expect you to do it as a fraction. So anyway, so make sure that you are writing it correctly as a fraction, because I will expect you to do it as a fraction or as a whole number. So if it comes out, if you get an answer as a whole number, it's fine. You can do it as a whole number. Now, in this example, in this first example, you have the table shows the relationship. So you have, I don't know, oh, here we go. I guess I wrote on there. You have miles X in seconds Y. So to calculate your slope, and again, I'm a fan of the Y minus Y over X minus X. So I would again start down here at the top end of your table, because you're going to be subtracting, so I think it's foolish to start at the bottom end. So whatever you start with in your Y, you have to start with in your X, and so that you're starting with the same point. So it's 25 minus 20 over, and then 5 minus 4. And make sure that when you're starting with those points, that you are, when you do that, that you are, that when you are starting with those points, that you start with the same point. And make sure that you are showing all of, ooh, what happened to my points? Oh, there they go. That you are showing all of your work. Okay? So 25 minus 20 is 5 over 5 minus 4 is 1. Now again, this is a perfect example. You have 5/1. You can leave that as 5/1, or you can write it as 5. Either one would be fine. Now you have to tell me what that slope represents. That means that for every 5 seconds, because it's 5/1. Ooh, look at this. It's all over the place. I'm going to erase that. Make sure you have that written down. If you don't, pause it and write it down. For every 5 seconds, because it's 5/1, for every 5 seconds, it is 1 mile away. For every 5 seconds, wow, yeah, too close. For every 5 seconds, it's 1 mile away. The lightning is 1 mile away. For every 5 seconds, oh, you hear 5 seconds after the lightning strikes, you hear the thunder. It's 1 mile away. That's what that means. So, and that's how you would write it. Okay, you have to explain it then in words. Okay, so, and they did it for you. For every 5 seconds between a lightning flash and the sound of thunder, there's 1 mile between you and the lightning strike. Okay, so I would like you to pause your computer And I would like you to try letter A. So you have to graph it and then calculate the slope and then tell me what it means. Okay, so for letter A, it says graph the data about plant height for a science fair project and then find the slope of the line. Explain what the slope represents. Explain what the slope represents and graph the data about the plant height for the science fair project. Okay, so I'm not going to be able to graph this because of the point, so I'm going to turn my answers on so you can just see what it looks like. So this is what the line looks like after you graph it. Now when you calculate your slope, y minus y over x minus x, I wouldn't use the decimals. You could, I wouldn't. I would just do the whole numbers, and I would do 6 minus, and I would go down to the 0.3. It doesn't matter what points you use. It really doesn't make a difference as long as you choose any 2 points and you go back to those points for your x's and your y's. So if I choose to go to the 6 for my y, I have to go to that for my y's. If I go to 6 and 3 for my y's, then I have to go to those same points for my x's. So it would be 4 then minus 2. So 6 minus 3 is 3, and 4 minus 2 then is 2. So your slope is 3 over 2. Now, this is an example where your book puts 1.5. That is wrong. You should not do that. So that's your graph, and there I calculated my slope. Now, to explain it, you would say that for every 3 centimeters, because it's centimeters, for every 3 centimeters a plant grows, a plant grows 3 centimeters every 2 weeks. It scribbles because if I get too close with my pen, then it scribbles. That's what happens with this surface, unfortunately. If you did that right, you can move on. If not, you should rewatch. Okay? All right, next page. Number 2. I'm going to skip number 2. Number 2 is the exact same thing, but I'm going to go on to we're going to go on to number 3. Number 3 is Jessica. Jessica has a balance of $45 on her cell phone account. She adds $10 each week for the next 4 weeks. In the work zone, graph the account balance versus time. Find the numerical value of the slope and interpret it in words. The first thing I would do is that you should do is you should create a table to organize your data. Okay, so she has a balance of $45 in her cell phone account. So there's the money, and then you have the weeks. So in 0 weeks, she has $45 because that's what she starts with. And then in the first week, then it'll be $55 because she adds 10. In the second week, it'll be $65. And then in the third week, it would be $75, and then it would keep going. Okay, so now you have to calculate your slope. So I would choose my 2 weeks. So I'm going to change colors here, and I would choose these 2 weeks right here. Okay, so now I got to calculate my slope. Y minus y over x minus x. Okay, so I would do 75 minus 65 over 3 minus 2. 75 minus 65 is 10 over 3 minus 2 is 1. So my slope is 10 over 1. Okay, so I created my table to put my information in. I calculated my slope, showed all my work, my formula and my work, and I got my answer. All right, now I have to graph it. Now I can't graph it with my pen, so I'm just going to turn my answers on here so you can see what it would look like, and there's my graph. Is that a proportional relationship? That is not a proportional relationship because that's not going to go through the origin, because she started at $45. So it's not a proportional relationship. But we're not talking about proportional relationships necessarily. Not all lines are proportional relationships, and all straight lines are going to have slope. So we can still calculate slope. Now, you have to say, what does this mean, this 10 over 1? Well, this means that Jessica deposits $10 each week. That's what it means. That's all. Okay? All right. So now your homework is to do your guided practice. Just one problem. Number 1. You need to calculate the slope. You need to graph it. And you need to tell me what it represents. Okay? Okay. That is it then.